Welcome to the 103rd installment of Ear to the Ground, the Land Stewardship Project's audio podcast on family farming, sustainable agriculture, local food systems, and local democracy. I'm Brian DeVore of the Land Stewardship Project. In some Midwestern townships, over 90% of the landscape, much of which is former tallgrass prairie, is now dominated by two row crops, corn and soybeans. These annual plant systems only cover the soil a few months out of the year, causing major soil and water quality problems, as well as leaving little room for wildlife or even pollinating insects. Back in 2003, a group of people in Iowa began discussing ways of adding some perennial diversity to crop fields in the region. Out of these discussions came a unique research project coordinated by Iowa State University's Leopold Center for Sustainable Agriculture. Since 2007, researchers have been growing strips and patches of native prairie on steep hillsides otherwise planted to corn and soybeans. The project, which is taking place on the Neil Smith National Wildlife Refuge in central Iowa, is measuring what environmental impacts these patches of perennial prairies are having not only in the fields themselves, but in the wider watershed. Scientists are carefully measuring soil and nutrient loss, as well as whether this natural habitat is increasing the presence of wild critters such as birds and pollinating insects. Recently, I attended a field day at the Wildlife Refuge and learned that the prairie strips are indeed improving the environment. In fact, they are working better than anyone predicted. In particular, research has shown that planting just 10% of a field to prairie can reduce soil erosion by 95%. This reduction in erosion has occurred at a time when this part of Iowa has experienced an unprecedented run of torrential rainfalls and floods. These storm events have caused significant erosion and runoff even on fields utilizing no-till production systems that disturb the soil as little as possible. After the field day, I talked to two researchers involved with this exciting project. Matt Helmers is an associate professor in the Department of Agriculture and Biosystems Engineering at Iowa State. Matt Liebman is a professor of agronomy at ISU and the Henry A. Wallace Chair for Sustainable Agriculture. First, Liebman explained to me the results of the research and how the prairie strip's ability to reduce erosion has become particularly important in light of recent changes in land use and weather patterns.
In Iowa, 65% of our land area is planted with corn and soybean. So there's some areas of the state, north central part of the state in particular, but even down to this area, where a very, very, very high percentage of the landscape is occupied by just two plant species. And we've lost a lot of our biological diversity. So originally we started thinking that, okay, we could put these strips in and conserve large numbers of species. Then as we moved along into the project, we implemented it in 2007 when the ethanol thing was really beginning to move down here, and we were seeing in Iowa several 100,000 acres of CRP ground coming out for people to plant more row crops. We began to think about, well, maybe there's some important soil and water conservation benefits that are also conferred by working with these strips of reconstructed prairie. 2008, we saw one of the largest floods in Iowa history that did billions of dollars worth of damage in eastern Iowa, including the city of Cedar Rapids. But here we saw massive amounts of soil erosion. 2010, we saw more rain coming back, 16 inches in the first 11 days of August. These kinds of high-intensity events are occurring with a greater frequency, and regardless of how people think that they're coming about, whether they're caused by people or just by a changing climate that evolves independent of us, they are things that people have to deal with. And in the world of farmers, they're looking at large amounts of nutrient loss, large amounts of sediment loss, increased threat to crop production. These kinds of things are catching people's attention. So as the project has come forward and we've collected a lot of numbers in these particularly challenging years, we've caught people's attention, and we've begun to gain a lot of traction with not just the wildlife conservation organizations, but with the commodity groups and the State Department of Ag and Land Stewardship, people involved with soil and water conservation. Well, as I mentioned before, we've had some very heavy rainfall years since we started cropping these watersheds in 2007. 2007 was relatively dry. We implemented no-till corn and soybean rotations in 12 of these watersheds that are managed with different amounts of the watershed in strips or patches of prairie distributed up and down the slope on the contour or at the bottom, at the base of the watershed. These watersheds run up to about 8% slope. They're quite typical of the area that's farmed here. It's not flat ground. And 2008, where we had heavy rains in late May and June, we were losing 11 tons of soil per acre out of the all-crop watersheds, where we were losing just several hundred pounds out of the bottom of these watersheds where we had strips or patches of prairie interwoven with the crops. So we have either 10% or 20% of the watershed in prairie in the stripped or patched watersheds. It doesn't seem to matter a lot whether we go up to 20, 10% seems to be enough. 2010, we also had a very heavy rainfall year. Same pattern, although the magnitude of soil loss was lower because the rain came in August. 2009, we saw a very similar pattern. Again, the magnitude was different, the absolute amount of soil loss. But in general, I can say that for a given year, under a given set of rainfall conditions, we can reduce soil loss 95% relative to the all-crop watersheds when we implement this stripped prairie approach. With that soil comes fairly sizable amounts of nutrients. In 2008, we were losing 60 to 70 pounds of nitrogen per acre in that soil sediment that was moving off, about 30 pounds of phosphorus in the all-crop watersheds. We were losing a tiny fraction of that, similar to the reduction in soil loss in the stripped watersheds. The other thing we're seeing is a reduction in overland flow of water. More of the water is infiltrating into the ground rather than sheeting off and shooting into the creeks and ultimately into the rivers. So from the standpoint of reducing that huge pulse of water that adds to our floods and putting more of that water in the ground, this stripped approach seems to work well.
And that's the question I had, and I think maybe you've partially answered it, but farmers in the Midwest are no strangers to grass strips, grassy waterways, that type of thing. But this is a little different because of the prairie system. It sounds like that's maybe a big advantage over just, say, putting in some cool season, a monocrop of brome or whatever.
Yeah, so one thing you'll see if you put 5 or 6 inches of rain across brome is it lays flat. And when it lays flat, it does hold onto the soil, will prevent it from eroding, but it doesn't really impede the movement of water and the sediment that water carries. The difference between using these prairie species, including a lot of native warm season grasses, is that they have erect, stiff stems that stand up and impede the movement of water. It basically serves like a filter strip, whereby the speed of the water and the force with which it carries sediment down that slope is reduced. So it's a difference in the quality of the vegetation that translates into its function in reducing soil and water erosion. And of course, as prairie species, they have flowers that provide habitat for a whole variety of creatures, including pollinating insects and beneficial insects that may prey on crop pests, and also provides excellent bird habitat.
Next, Helmers discussed how targeted conservation on just a small percentage of acres could produce a disproportionately large positive effect, and how surprised he and the other scientists were at the dramatic reductions in runoff and erosion the prairie strips produced.
And my background is doing a lot of work on buffer systems, and really what you see is that with that buffer, that leading edge does a lot of the work from a water flow standpoint. And so once you get beyond the first few meters or the first 10, 20 feet of that buffer system or that strip, there's some water infiltrating, but there's not a lot of sediment in that water. And so, that leading edge, that small percentage right at that interface between the cropland and the native prairie does a lot of the work. And so you see, if we go from 1 to 5 to 10% to 20%, we're going to see a big jump in how much benefit we get with that, 1, 5, and 10, and then maybe a little bit leveling off as we go from 10 to 20%. So, and then beyond that, kind of, again, somewhat leveling off of the improvements, say, in water quality. With our project, we're also monitoring a 100% prairie system, and we do see, less total soil loss from 100% prairie than if we have only 20%. But, incrementally, we have, an 80% increase in prairie there as well. And so we're still trying to look at the working land, within the row crop system, but can we take a small percentage of that and get these big benefits?
Yeah, I think that's another interesting concept, is this idea of often when people talk about getting more perennial systems on the land, some people say, well, they go to the extreme of, you want to turn all of our corn into, the Buffalo Commons or the tall grouse prairie. But this really gets at the idea of if you can get those key areas in some real critical spots where there's, I guess, almost strategically placed, but that you don't have to do a whole lot.
I think that's exactly right. I think we, with a lot of our precision agriculture and precision conservation, we can determine what areas of fields may be contributing the most to sediment loss or soil erosion. And so, if we target those areas, we can hopefully have a big benefit. Exactly. We're not saying that, okay, we need to turn all of that land back to tall grass prairie, but can we convert some of those most sensitive lands into some type of perennial cover, in this case, the native prairie or restored native prairie cover, and get some of those benefits that we want.
It seemed like when you were presenting the results, it's a little bit intuitive that you would see a reduction, but you seem to be kind of surprised at how dramatic some of the reductions were.
Yeah, we've seen about a 95% reduction in sediment with these strip systems. 95% reduction in sediment export from the watersheds with the strips. And I was and am surprised that it's that dramatic. I've done work in the buffer area, and even on plot scales, plot scale with uniform flow conditions, we still, we may be up at that 90 to 95% sediment reduction, but now we're dealing at more of a hill slope scale, and we have natural flow pathways that are tending to concentrate flow. And even there, we've been able to dissipate that flow energy and drop out that sediment. So it's very encouraging that these systems can work even when we have what I'd call kind of the natural flow of concentrating flow areas. A lot of the buffer research had been done on more controlled scale with uniform flow across the leading edge of the buffer, and our work is really under natural flow conditions, and we've still seen dramatically positive impacts from a sediment loss standpoint.
Finally, Liebman and I talked about the next steps that are needed in order for this research to result in more perennial plant systems being established on working farms. One of the things that's really become clear to me is the results are in, and it's pretty dramatic. So what are some of the next steps as far as trying to get this actually implemented on the land? We talked some of the small groups here talked a little bit about that.
Obviously we'd like to upscale and operationalize this on a much wider basis, but to do that you have to have land managers, farmers, and people who rent land to farmers buy into the idea and see it as desirable. So some of that is providing the numbers. We had people here saying farmers do really well just looking at the raw data or some digest of it. And, when you're seeing cumulative soil loss over a, say, 5-year period of somewhere in the order of 25 to 30 tons an acre, that kind of catches people's attention, whether they're landowners that rent their land out or people who farm it. So yes, we have to do a better job of selling the information that we've produced here, but we also have to reach out to policymakers and those folks who can provide some of the economic incentives from government to encourage farmers to implement some of these conservation practices. It's in many cases very difficult for farmers, particularly those who rent, to take some land out of production. Even though that they get these disproportionately large gains in conservation, they're under the short-term pressure of producing a valuable crop on as many acres as they can. So we're going to have to come to some agreement about how we balance conservation with increased productivity. We know that the markets for crop products are good right now, that prices are high, but we shouldn't devalue the importance of our soil and water resources, and we've got to come to a broader agreement as a society as to how we're going to compensate and support farmers for that conservation service that they can provide.
It seems maybe one avenue is to really emphasize how the multiple benefits that could come from something like this, that you could get maybe a market for biofuels, but also wildlife habitat, and that would help bring in maybe some more partners, either from the private sector as well as some of the nonprofits, that type of thing.
Yeah, I agree. There are a lot of benefits that we gain from here, and some of them are a little harder to put a monetary value on. So, we see more carbon stored under prairie roots by prairie roots than we see under corn and soybean. I don't know what that market is, and I don't know where that market's going to be, but we know that it builds soil fertility and it builds the long-term productivity of those soils. In terms of soil and water conservation, yeah, we can put a value on the nutrients lost in soil sediment or the reduction in reservoir capacity, things of that nature. But, how much are people willing to pay for that? I'm not sure. Yeah, we could see some markets evolve for biomass production, either for direct combustion of pelletized materials from these strips, or maybe we have some conversion technologies with heat or enzymes that will put them into liquid fuel. Those are all part of that portfolio of payments we might steer towards farmers for not just soil and water conservation, but some of the other services and goods that they might provide. But I think we have to approach it from the standpoint of helping people do the right thing. And in some cases it's going to be markets, and in other cases it's going to be conservation payments that might otherwise be directed towards crop subsidies or something else. We have to come to some broader agreements. Protecting the long-term productivity of our farmland is really important to all of us, not just those who are farming it directly.
The Prairie Strips research in Iowa has a lot of people excited about the possibilities offered by establishing perennial plant systems on relatively small, targeted areas of the farming landscape. In fact, that's the basis for the Chippewa 10% Project, an initiative of the Land Stewardship Project and the Chippewa River Watershed Project. The Chippewa 10% Project is working to make strategic establishment of grasses, trees, and other perennials in a small percentage of one western Minnesota watershed profitable for farmers. For more information on the Prairie Strips research in Iowa, see www.leopold.iastate.edu. That's leopold.iastate.edu. And search for the keywords Prairie Strips. For more information on the Chippewa 10% Project, see www.profitsfromperennials.org. That's profitsfromperennials.org. If you have comments or suggestions about this podcast, contact Brian DeVore at bdevore@landstewardshipproject.org, or you can call 612-722-6377. Thanks to Laura Borgendale, Western Minnesota musician, for Ear to the Ground's theme music. And a special thank you to all of Land Stewardship Project's members who make initiatives such as this podcast possible. If you're not a member, visit landstewardshipproject.org to learn how you can support LSP. Thanks for listening.